Um, I, yeah, I mean, I guess I do. Quadratics are probably my favorite, but I like this. This one is a very calculator-driven unit. And we'll get to that in just a second. Let's first talk about the test. The test yesterday, so you see the results on the board. Um, Class average was an 88.3, which was really, really good. I was most happy with your range of 75 to 100. I like the range a lot. Um, Now, I want to kind of put it in perspective. Um, so yesterday, y'all took what was an academic level test. When the person was making the copy, so you have two different types of algebra. You have academic algebra and you have pre-AP algebra. Y'all are in pre-AP algebra. Academic would be like for the kids who are now in like regular 8th grade math and they take algebra when they go to high school. So the person who was making copies of the test copied that test instead. So I discovered it yesterday morning. Miss Alborn and I talked about it, and it was like we'd already made all the copies, and it seemed very wasteful to like throw away 200 copies of a test just to make 200 more copies of a test, right? So we're just like, let's just let them take the academic level test. So we did. Everything's fine. I don't want it to like take away from your grade because good grade's good grade. Land it, lock it, load it, right? Put it in the grade book and be happy with it. But I do want you to have some perspective about it. Because I think for the most part, most of y'all would agree that as you were taking the test, you were like, this isn't that tough, right? And it was shorter than normal. It was only 16 questions versus 20 questions. Here's the rule of thumb. I will tell you that based off what I saw, if you scored below an 88, then more than likely the real test would have kicked you around a little bit. Okay? And I mean, it is what it is at this point, but I do want you to understand that, like the EOC is going to be written at a little bit higher level. Obviously, Unit 10 test, the retest is today after school for Unit 9. By the way, Unit 9 retest today after school. If you're retesting for Unit 9, the CMS assessment, that's today after school. So make sure you're here, okay? That's at our normal regular level. But you got a break, do what? Yeah, absolutely. You got a break, no big deal, yippee, but just know that, okay?
When will we be able to see like what mistakes we made?
I'll give it out today. You'll have time to see it today. I'll pass out the test and pick them up today. So I also have, if you want it, like towards the end of class, once you're done, I have because the retest is based off the CMS assessments. So I have the answer keys for the CMS assessments where I've worked them. So it probably wouldn't be a bad idea if you're going to retest to at least kind of glance over the key just so you can kind of refresh your memory about what's going to be on there, and then you can ask me questions. That way you can ask questions before we test. Okay? So let's get into today. Today we're going to start Unit 10. Unit 10, if you look at the schedule, we are only in Unit 10 for 4 days before we start EOC review. It's day 1, day 2, day 3, day 4. So Thursday, Friday, Monday, Tuesday. By the way, interview in band, if you're going to be gone tomorrow, make sure you fill out a green slip. Okay? But after Tuesday, on Wednesday, Thursday, and Friday of next week, we're reviewing for the EOC. That's where we're getting ourselves ready for our big finale. Really. Okay? And I want you to use that time wisely. When y'all did the homework last night on those writing equations, I would imagine, like, once you started talking to your friends or looking it up or whatever, it started to come back. You're like, oh, yeah. You had those oh, yeah moments where, oh, yeah, that's right. That's how I write that. The same thing's going to happen with all of algebra. There's a lot of algebra you haven't seen in a long time. But as you do those little one-page reviews and check them against the answer keys, you're going to have those oh, yeah moments. You go, oh, yeah, that's right. Those oh, yeah moments are what get you ready for the test. So I want you doing as much of that as possible. If you spend those 3 days not doing what you need to do, you will not do well in the EOC. You just won't. You have to get yourself ready. I think you'll find, guys, I genuinely think you'll find, as you spend those 3 days wisely, that you know a lot more about algebra than you think you do. Even those of you that may have struggled during the course of the year, by the end of the year, you start to really get it. Okay? And the goal is for you to walk out of the EOC feeling like you did yesterday when you finished the test. Like, I think I did okay on that one, right? That's what we want you feeling when you walk out of the EOC. But the only way that happens is if we get ourselves ready. So we'll review Wednesday, Thursday, Friday. That next Monday, the day before the test, we will do no review. Y'all will come in here and we're going to sit down and talk. That's all we're going to do. I'm going to share out with you some strategies, some things to think about, kind of get you chill and ready for the test, and then that's it. Walk in Tuesday morning and stick the landing. That's what your job is. Your job is to come in Tuesday and stick it. Period. I want 100% commended. I want you to be 100% commended because I want you walking into high school going, I got this. That's what the goal of algebra is. So you know that you are absolutely high school ready. Okay?
Did you say no one has ever failed BSC?
Not at Cockrell.
Like, actually?
Not at Cockrell. Not since I've been teaching. Not in 4 years. Wait, 4, 5, wait, 1, 2, 3. Not in 5 years. I've been teaching algebra for 5 years. We've never had anyone ever. We were 94% committed last year, for goodness sakes. Now I would like 100.
Well,
I want 100. No, well. Oh, no. 100% committed. Yeah. Oh, no. No, we don't do that try thing. This is not, no. The world does not reward effort.
You need to quote Yoda.
Do what?
You need to quote Yoda.
Nah. I'll quote mine. Okay, here we go. Let's get into Unit 10. Unit 10 is about exponential functions. Exponential functions have certain characteristics that you will begin to see. The cool thing is, it is a lot of calculator. Yay! It's a lot of calculator. So let's talk about how we enter in an exponential function. So if you go to y equals, and you type in 4 times 2 caret x, and you go to your table, then you can enter in table values. It shows me that negative 2 has a y value of 1, then that's 2, then 4, then 8, and then 16. Those should have been the values you got. Now that you have x's and y's, you can graph them. We graphed to negative 2 and 1, which is there, negative 1, 2, which is here, 0, 4, 1, 8, and 2, 16. Now it says do not connect them because I didn't want you to connect them yet. Because most kids, when they connect them, they will do something like this and connect them. That is not the way an exponential function works. Exponential functions are very, very unique, and let me talk to you about why. Exponential functions deal with percents. Percent growth and percent, like something getting a certain percent bigger and something getting a certain percent smaller. And the way it looks on a graph is very, very unique. And I want to use this as a description real quick, and this will help you understand. I want you to listen to me. If I am standing here, and I want to walk to that wall, right over there, and I decide my strategy for doing that is I'm going to start right here. I'm going to walk 50% of the way to that wall, and I'm going to stop. Okay? So 50% of the way to the wall, I'm going to stop. Then I'm going to walk 50% of the way again, and then I'm going to stop. Then I'm going to walk 50% of the way again, and then I'm going to stop. And I'm going to do that over and over again. 50% of the way. How long is it going to take me to get to the wall? I will never get to the wall. Because each time I'm going halfway.
I'm sorry.
Understand? So let me put it to you this way.
Let's one half.
No, just watch. Julia, say I have, let me do this so that the person who is watching this can know. Say I have a stick. And I'm going to cut it in half. So, done. Then I'm going to cut the half in half. Then I'm going to cut the half in half. Then again. And each time I cut it in half, when do I run out of stick?
Never.
I never run out of stick. The sliver gets infinitely small because each time I'm just cutting it in half. But I never get to 0. If I'm walking halfway to a wall each time, I'm just going halfway, but I never hit it. Because each time I'm just going in between where I am and where the wall is. And then where I am and where the wall is. So when you look at the graph of an exponential function, here's what happens. This is the way it looks. It looks like this. Where as it goes to the left, it is getting closer and closer and closer to that x-axis.
So that x-axis is like the wall over there.
But that's exactly right. But it never gets to the zero. It just gets infinitely closer. That's the way an exponential function works. It just does this. Now, when we look at this over here on the other side, let's punch these into our calculator. So we punch in our calculator 4 times 0.5 caret x, and we hit enter. We go to our table. What we end up with is negative 2, 16, negative 1, 8, 0, 4, 1, 2, and 2, 1. And when we graph those points, we end up with here, and then here, and then here, and then here, and then here. And if we connect those lines, what it ends up looking like is this. Except it's flipped. So here's my question to you. When you look at the two equations that you see in front of you, there are two equations here, guys. Here's an equation, and here's an equation. They look very, very similar. There's only one difference between the two. Katie, what is it?
2 is the 2 on number 2 is like split.
What do we call this number?
The reciprocal.
Sort of. You're right. No, it is the reciprocal. But what do we call it in an exponent form? Remember when you first learned about an exponent, there was this dude and there was this dude. What is this guy called? He's called the base. This is the base number. This is your base number, and this is your exponent. The bases are different. And even though they only changed by a little bit, you're exactly right. They became the reciprocal. They completely changed the way those graphs looked. They completely changed the way those graphs looked. By the way, where's the y-intercept on number 1? Where does that thing cross the y-axis?
4.
Huh.
Well,
It just makes it like.
Well, let's see. Let's go to the next one. On number 3, we're going to plug this one in. We end up with 0.5 times 3 caret x. 0.5 times 3 caret x. Oh, I got crazy decimals too. Let's see. I end up with like 0.05 repeating, 0.16 repeating, 0.5, 1.5, and 4.5. Now, based off those table values, does it look like it's an increasing function or a decreasing function? It's increasing because notice the values, guys, are getting larger as you go this way. Let's see what it graphs like. Now, I don't even know how to graph that, so I'm just going to kind of estimate. It's going to be like a best guess. I go to negative 2 and there. Negative 1 is really there. And then there. And then 1 is at 1.5, which is here. And 2 is at 4.5, which is right here. That's where I know, I just graphed it. Is it an increasing function or decreasing function? What do you notice about the value of the base, the number in front of the exponent? It's 3. So it's an increasing function. By the way, look at our previous ones. Which one was increasing? The one with the base that was what?
full number.
2, right? Yeah. So we have a common thing there. Where's the y-intercept?
0.5, same number.
What is 0.5? Oh.
Look at that.
Oh, well, wait, what? Oh. Oh.
Remember your base is 1.5.
So wherever the x
I don't know. Let's see. Let's go to the next one. On the next one, we have 5 times 0.5 caret x. We go to our table. We end up at negative 220, negative 110, 0, 5, 1 at 2.5, and then at 1.25. And so when we graph these, we end up at negative 220 right there, negative 110, which is here, 0, 5, ooh, y-intercept, 1 at 2.5, and 2, 1.25, so here. So is it an increasing function or a decreasing function? It's a decreasing function. What's the value of our base? Yeah. So based off the 4 things we saw, how do we know if it's increasing or decreasing? Where do we look, Riley? At the base. And what value of the base makes it increasing? Saya? Anything? No. Because 1/2 is greater than 0.
Anything cold.
No. Thank you, Cameron. Anything greater than 1. Score with the right answer, even though you were shocked about it. And how do we know when it's a decreasing function? When it's less than 1. High five for you. You didn't appear shocked, though. Yes.
What happens if the base is a negative number?
Huh. Well, if the base is a negative number, it's... Don't know. You know what you could do, though? Ah, look at that. Picking up your calculator. Being a smarty at a party. Today is about discovery. I want you to learn about exponential functions by doing the classwork. Now, really quickly, what I do want you to understand is this. Growth means to get bigger. Decay means to rot and get all gross, right? Exponential growth and decay are all about things that are either getting infinitely larger, like this, or about things that are getting infinitely smaller. Now we say infinitely smaller because it never gets to that 0 place. It never gets to that 0 place. Yeah, it's a shame. It gives us something to do, though. So when we're looking mathematically at exponential growth and decay, this is an example of exponential growth. This is an example of exponential decay. How do we know?
Sorry.
It's okay. How do we know that this is decay, Cameron?
Because it's less than 1.
Because it's less than 1. I know.
Amazing.
Shock and chagrin. And this is larger than 1. Now, I want to do a quick conversation. How do we know? Someone tell me what linear growth looks like. Linear growth. Very good. It does. It looks exactly like this. Right? It's a linear line. That's stupid. It's a line with a positive slope. You're now learning about your third function. You should know what lines look like. Increasing lines, decreasing lines, 0 lines, undefined lines. You should know about parabolas, wide and narrow, facing up and facing down. And now you're learning about exponential functions. Exponential functions will always, exponential growth will always look like this, and exponential decay will always look like this, no matter what. You will never have exponential growth and decay on the same graph. It doesn't even make sense. It's like saying you have linear growth and a linear increase and a linear decrease all at the same time. That doesn't make any sense.
What if they're measuring two different things?
They wouldn't be on the same graph. Okay? Yes?
How do you measure how old you feel?
How do I measure how old I feel? I take the log of 7 and subtract it from 6. Okay, here's what you got. You're going to be exploring exponential growth and decay. You have 2 pages of classwork in your brand new packet that you just got. Natalie, focus. Where's my tennis ball?
You feel negative 5.15
Listen to me. This is going to be something where this helps you. Use your calculators to graph functions if you can't create a mental image for them. Okay? Go through both pages of classwork, check your answers, then you can pick up your homework and get going. While y'all are doing that, I'll pass out your tests. Y'all can take a look at them. I'll also print a couple of copies of the CMS assessment key. Who all wants to see the CMS assessment key at some point today? Okay, I'll make 3 or 4 copies for each table group. Okay? And then after that, we are good to go. Any questions? Rock it out. Test it.